So let's start this week's lecture by talking about last week. I was really happy everyone was able to get their projects in. I realized by reading the narratives, which I really enjoy reading, they're very insightful, that a lot of you spent a lot of time working your way through Revit issues, just relearning the program. And so I apologize for the extra time it took you. I hope that's pushing up the learning curve so that you'll be able to go through a lot of these functions quicker and hopefully to your benefit. One of the comments in, or one of the things I flagged in the M1 I'd like to discuss a little bit. Oh, sorry, I forgot one other thing. I changed out M3. I just wanted to tell you kind of what I was thinking about this week. Kind of with the comments in lecture about where you were with Dynamo and other your comfort level with it. I took out the project that I originally had in there and put in what is the last project that I assigned in Computer Viz for learning Dynamo. And I thought it was a lot more rewarding visually and more interesting, so I hope you'll enjoy that. Once again, before we get back to last week, on the submissions, please pay attention to the nomenclature that you use for labeling it. Like, for instance, this should be A8753 with your last name. You know, this whole labeling convention of the file will be very helpful for what you have to do at the end of the course, which is to archive your 15 submissions, which shouldn't take much more than a few minutes to put them all in a zip file and submit them. And instead of a PDF, they'll obviously be a JPEG file. So you might want to just start doing that by starting to label these right away and making a file for them on your own computer so that in the end, when we finally submit them, you'll have them all together. So back to our rain screen system. I wanted to play this video. It's kind of amusing, well, in a bad way, but I think it's quite visually shocking to see a new home under construction falling so easily. Looks like they had decided to demo the house before they had completed it for some reason. Whether it had wind damage or something to it, I don't know. But one of the things that it makes you think about is this idea of how weak these structures can be if they don't have proper shear wall construction in them. And one of the problems with the exterior sheathing systems that we use in a lot of our new building materials, and we're substituting out plywood, is to pay attention to what the sheathing is and to realize that the function of these exterior walls, the way they're fastened in, become part of a shear wall performance. Now, in our project, we're actually really making curtain walls, so we don't have the necessary requirement of shear wall performance, but we still have this idea of resisting lateral forces, and so I wanted to kind of like punch up on this issue. We're going to discuss it a little more. Actually, in M1, it could be a curtain wall. It could also be a shear wall. But a lot of you labeled the sheathing as drywall or gypsum board. And gypsum board is used, moisture-resistant exterior grade gypsum board is used as a sheathing material. But what I caution you there is that it is not a structural material in and of itself, at least in some of the ways that it's rated. So pay particular attention to that. And also the use of gypsum board is relatively a new material to be used. Typically it's done to reduce cost. There really isn't many performative issues that are improved by it. And I would encourage you to just spend a lot of time thinking about it before you select a gypsum board material as an exterior sheathing. For instance, there's all kinds of grades of plywood and oriented strand board that will have the same kind of barrier protections, but without the problem of moisture and other structural issues with it. But you for sure cannot label an exterior sheathing wall as just gypsum board. It must be characterized as a moisture resistant material and a sheathing grade exterior material. Labeling it as gypsum board would just be completely inadequate for that application. And a little more expansion about kind of where we talked about with rain screen. I just saw this article, so I wanted to kind of reintroduce it. In some of the discussions we had last week, we talked about this idea of stucco systems and how they kind of brought on this maybe a stronger genesis in the industry to look at rain screen systems because of the ability for moisture to get behind them and then not be able to get back out. And Stowe, Drive-It are some of the manufacturers of these kind of early stucco systems. And because they were polymer based and not synthetic stuccos and not real stuccos, they couldn't vent moisture like conventional stucco could. And so they would trap moisture behind it. Now, why I'm showing you this article is really driven by this advertisement I saw was sent to me in Architectural Record, suggesting that I visit Stowe or their content about rain screen cladding systems. And the amusing part of it is Stowe is one of the first people that created these kind of problematic non-rain screen systems. And now they're in the forefront of promoting rain screen systems, actually to the point where they call rain screen a registered trademark of their company. And then here's the illustration that goes along with it. So nowadays they promote the exterior stucco, synthetic stucco systems, but they put it in a rain screen system, which you could be familiar with. And that's because you can see the construction of the wall, then the air and moisture barrier, then the insulation, all on the exterior of the building. So there's a bit of irony about that. I have a link here to an article from 1999 about stucco systems. Oops, excuse me. So you may want to visit that also. So a couple of projects caught my eye. All of them were well done. I think everyone got an acceptable grade. This was one that obviously designed the system and then went the next step. I found it to be very visually interesting. I found the mix of color tile and three-dimensionality. One of the reasons I wanted to bring it up and discuss it too, though, is also these extruded tiles really don't have this ability to create dimensional curvature in two planes. If it can, because this tile is curving in a triangular form where it starts low and goes high, that can't actually be done in a conventional extruded clay tile. And I didn't want that to be accepted per se in the application as I was presenting it. And I want to, but there's really inherently nothing wrong with this type of tile system. What is the issue is how it would be manufactured. And so we would move from an extrusion type of construction of this tile to what's called a ram pressed. And we can talk about visiting Boston Valley Terracotta's website to kind of see the distinctions there. But one of the most pressing issues about moving to these more complicated techniques of forming tiles, and I have an example, and I think this is a link to the Boston Valley site, which will take you into some of the techniques that they have available to them. But I don't want to get too distracted here. What I want to really kind of point out here is that they do make these type of tiles, and here's a great example of a ram press tile still in a rain screen format on the exterior of a building, but the cost differential between a flat tile and this is significant, and something that you would want to consider as an architect, and just the idea of moving from one manufacturing technique to another. Mostly so you don't introduce an expensive style before you've even decided what style you want to select in a project. This is another nice project, caught my eye. Just I thought the idea of the color scheming was very attractive. I see a lot of these color schemings that I don't find attractive, so this one I thought was nice. This requires glazing the tiles, which is a secondary treatment, but it's very commonly done. And then I wanted you to, well, let me just take you to a slideshow. This was from last year. I think it's worthwhile to maybe just step you through this. Boston Valley hosts an architectural ceramics assemblies workshop, and the participants are from all over the nation. You'll recognize the architectural firms as leading architectural firms in the industry. They're given somewhat of a free hand to come up with an innovative use for architectural terracotta, and they're all architects designing for architectural applications, and it's really quite interesting to see what they come up with. In this case, Kieran Timberlake came up with the idea of extruding these clay cylinders and then motorizing them with an actuator and a ball to actually create different noise, using them almost as bells. And we can always discuss the practicalities of some of these ideas. Sharp Shop Architects, another huge, well-renowned firm, um, introduced the idea of ram press formed tiles that could be combined to create both structure um, um, and cladding, or at least some, maybe we'll just leave it at cladding. Pelly and Clark Pelly Studios introduced the idea of modifying a common extrusion by using a robot to bend a flange. And they had various levels of success with this. Their tiles reflect probably a lot of reworking. They had a lot of trouble with trying to form these edges. But it was an interesting approach to how you could modify tile systems to create fin systems. Payette, patterning, lighting, maybe interior applications, not necessarily excluding exterior applications, but ram pressing. And then really far out kind of structural designs of trying to use cable systems with inside of tile systems. UB presented a way of water jet cutting tiles and then stacking them. SOM, a way of, once again, either wire cutting them prior to finishing or water jet cutting them as a secondary operation. Water jet cutting allows you to cut a really difficult to cut materials very easily by creating a high pressure water jet with some abrasives in it, and it allows you to cut through just basically anything you want to without damaging it. So here we have some conventionally extruded tiles and then a secondary cutting operation to expose the interiors for visual interest. And you can decide if these are effective or not. Here's a tile now that's been extruded out by another workshop, and I don't know who this was that year. An idea of using tile systems to combine to create a panel system. And I want you to think about this as a spandrel panel because you'll see an example when we talk about curtain wall construction that shows how this idea of patterning and building these systems up could be used in architectural ways on high rises with unitized construction. This is from Alfred University. Jonathan's project was using, I believe it was, and this is a year ago, they've already had another presentation. I believe this, and I believe that might have been Jonathan's project with the benches, but I'm not exactly sure. And but the idea here was to create these cardboard forms for slip casting ceramics. So we had a full gamut of participation. You can take architectural ceramics very seriously as far as its use in the industry and how well it is respected as far as applications. And we could talk more about that maybe later in the course. So the next video that you'll see is really a discussion of the rain screen as curtain wall, and that's going to be in a separate video.